In this tutorial, we'll have a more detailed look at the Comp3D effect. The Comp3D effect is a core function of Mamba. It's the central compositor. As we saw in the previous tutorial, if we have a clip that has an alpha channel, then by default, the Comp3D will composite that foreground layer with its alpha channel over a background layer. In fact, what's going on in the Comp3D is that we have a background which is set as input 1, which is this. So this is a static background in this mode. And then in addition we have a layer. Each input to the Comp3D, other than the background, becomes a plane within a 3D block of space. And it's the layer folder that carries all the parameters about where that plane exists. So for example, using the controls and in free transform, we can move that layer around. So that's just moving in the X and Y directions. Alternatively, if I were to hold down Alt, I could rotate in the Z axis, or if I were to hold down Control, I could scale the image. The axes lines here can also be used to restrict movement by holding down Shift. So I've now got Shift held down and selecting the Y axis only, you can see that I'm making a movement constrained to only Y movement. Combinations can also be used, so Shift and Alt will now only rotate in that axis. Alternatively, we can pick one of the restricted manipulators, so now just with the left button only without any modifiers, I'm now making rotational changes. When you're making scale or rotation changes, Mamba measures the movement of your cursor with respect to the center, so you'll find that you'll get a finer movement if you're away from the center than if you try to control it right near the center. I'm just going to select the folder and click delete to reset everything. The pivot obviously allows us to change where we rotate or scale around. Apart from our layer having a position in this block of 3D space, we also have a camera, and it's in this folder here. So the camera has an X, Y and Z position, and it points at a particular place in space set by the target. It can have a roll added to it, and this is the degrees of angle of view, so the lens. And if we're working in stereoscopic, this is the distance between two virtual cameras. So in the same way that we have manipulators for the layers to position the layers, we also have the same for the camera. So on orbit, this will orbit around the scene. So effectively that's rotating the position of the camera, but always maintaining the position that it's pointing at. Alternatively, we can dolly the camera in and out, or we can rotate the camera. In this case, the camera is staying in the same position and simply changing what it's looking at. And free transform works much the same with the keyboard modifiers as the manipulator axis layers. Over here we can also set in some constraints. We can change our view position, we can reset the camera position, and we can control what aspects we see on our display. If we look into the layer, we can see that we have a number of folders and subfolders. The most obvious one being transform, to make a position, rotation, size and pivot to our layer. For those not used to working in a 3D space, it's worth looking at the difference between positioning something in Z and making something bigger or smaller. So I've selected those and I'm holding down the middle mouse button to drag those two together. On the face of it, they seem to be doing the same thing, in that they both seem to be making the image bigger and smaller. Actually, they're not. If I just reset this, and I'm going to set the pivot down to the bottom of the frame, which is where it's going to scale from. And then we're just going to change our angle position so we're looking no longer square on. If I change the size, you can see that that is exactly what's happening. The image is changing size in the scene. On the other hand, if I change the Z position, you can see it's not getting smaller. It's just going backwards and forwards. So when we look square on, it looks like it's getting bigger or smaller. It's not. It's just going further away. And this has a relevance when we start layering up things as to priorities, and also when we start moving the camera around. At the moment we have one layer input, although we appear to have two inputs going into our Comp3D. That's because background is set to input 1, which means that this input has been stolen effectively and used as the static background. We can override that and switch it to a solid color, the color being black at the moment. So now what would happen if I went into free transform would be that we can see that both of those elements are moving together. If we want to move them separately, what we should do is add a second layer. So now I have a layer 1 and a layer 2. So layer 1 will be input 1, that'll be the background, and layer 2 will be the foreground. Normally when you add layers, these folders will add on their own. But if you need to add layers manually, the button's here, likewise to remove or to duplicate a layer. Duplicate layer will simply take whatever you've got highlighted and create a duplicate folder with all the same parameters. It won't actually duplicate what's going on in the nodes, it's just a parameter thing. You might have noticed that when I had one layer, bearing in mind that we set the background to be black, you might wonder why both images are moving if there's only one layer. This is part of a input rule thing with a Comp3D, which is normally you'd have a layer folder for each input. If you end up in a position where you have less parameter folders than you do physical inputs, then Mamba simply gangs together all the excess layers and puts them onto the one layer. So in this case, it's reading two inputs. There's only one folder, so it moves them both together. And the layer priority is set by the input. So input 2 is in front of input 1, even though they're technically on the same Z location. Let's go back to 2 layers. So I'm duplicating the layer, and I'm going to set this one back. So now we can see, as we move the camera around, there's a perspective difference between the two. The location of the planes is obviously set by the parameters here. It's also actually set by axis 2 and axis 1, which are additional offsets that act on all the layers. So for example, this is moving all the under layers together. So it just gives you a hierarchy of transformation parameters. If you want to add animation, then of course you can just enable auto key. So for example, starting here, moving here, back up to there. And of course those parameters are all shown on the keyframe graph as we've seen before. If we want to add in motion blur based on the motion that we've added in, then up in options, there's two things we need to do. Firstly, we turn up the samples, and then secondly, we add in a shutter angle. So 180-degree shutter angle, for example, and that's adding in some motion blur, but let's exaggerate that movement so that we can see it a bit more. So that's a bit clearer of how much motion blur is going on. You can set the samples here. The higher you set it, the higher quality motion blur you'll get, and the longer it will take to process. But as you can see, it's not particularly slow. You also use the samples for anti-aliasing as well. So without motion blur, most of the time you just leave this on 1. But if you're perhaps sizing something down a lot, just zoom back in, then you'll find the quality will increase with the resampling if you increase these. Let's just reset our view. In fact, let's just reposition our layers and camera back to Unity. Let's just go back to a single layer over our background. So I'm just going to remove that layer. Within each layer, apart from the transform that we've looked at, the attributes folder sets certain parameters for the layer. So attribute blend, for example, here, which we'd animate if we want to fade a layer up and down. We can set the blending mode for the layer, so how it's composited. The other items are related to doing 3D deforms, and that's in the next folder down. So jumping straight to the middle one, torus. In fact, if we just offset our camera just so we can get a better view. This basically allows you to do a 3D curve on the plane of the image. So this will curve around the y-axis and this will curve around the x-axis. And you can change the radius and tighten up the corners and so on. There's also a basic 3D wave generator, so you can make your waving flags, etc. Then there's also a displacement map function. So what this does is takes the luminance value of a second input in order to push in the z-axis plane outwards. So to use this, firstly we need another input from which we'll take luminance values. So to make it obvious, let's just go to a wipe and we'll pick something like this. Because a wipe, when it's not connected to anything, will just give us a white on black mask. Now by default, wipes animate, and they animate in the grade parameter. So I'm just going to select each of these and delete them. So now I have a static pattern. So I'm going to give that to Comp3D. Now, of course, Comp3D believes this is a new layer, and in fact, it's given me a new layer ready to go. Actually, on this occasion, I don't want that. So I'm going to remove the layer, and instead, in the attributes, I'm going to say I've given it a second input to act as a displacement map. So now what we can see is our image is being pushed by the luminance values in this image. The reason the pushing out is curved is that within the displacement map properties, there's a blur, which at the moment is set to 1. So that's blurring the luminance values of this before it's being used to push out. So obviously the more blurred it is, the curvier the push out will become. The other function affecting the accuracy of the push out is this subdivide number here. The lower it is, the faster the processing will be. The higher it is, the more accurately the push out will reflect the luminance changes in the second input. You can combine all these 3D deforms in order to make whatever weird shape you're wanting to make. You'll notice the object has a basic level of light and shade on it, and where that's coming from is our ambient lighting is set to 1/3 in each channel at the moment. If we wanted to remove the shading altogether, then we would set these to be 100. You'll notice even if you just rotate a plane away from direct view, you'll see it'll start to shade. So if you don't want that, just switch these to 100 and then you won't get any shade. So the ambient lighting is one set of default light. The next set of default light is what's just called light 1, and it's set to being a directional light. So in default mode, the combination of that ambient light and that directional light would give you unity brightness with the camera and the layer in their default positions. You can of course alter the lights, so changing the direction of the directional light or changing it from directional to being, say, a spotlight. We can also add in multiple lights. So for each light you have their position, their aim, the color of the light, and then depending on the type of light, various parameters that will affect how it plays on the scene. Going back into layers under attributes, there's also some control over the specularity of the surface. So this is how shiny, etc. a surface is. I'm just going to click delete just to bring ourselves back to a default layout. So a couple of other things then for each layer. We have a crop, pretty simple, crop left, up, right, etc. And the easiest way of accessing that is from the framing tab. We can crop our layer. And that crop is connected to the layer. So if I were later to move things around, you can see the crop is moving with the layer itself. Then also there's corner position. This would normally be used with the tracker in order to make 4-point tracking work. But essentially within the tracker folder you have the relative positions of where the corners end up. So this, for example, is moving, in this case, this particular corner of layer 1. Actually the part of the image that it moves is what this offset folder does. Offset and tracker, if I open them both, they seem to have the same set of parameters. In fact, they're negatives of each other. In tracker, this is actually where I'm going to place the corner. In offset, this actually relates to the input image and where that corner is being pulled from. So at the moment, the upper left corner that is being pushed around by the tracker is defined as being the corner of the image. If, for example, I change this to 50, what's now happening is that the corner that this is pulling around is actually halfway along. But in the most part, we would use corner pinning with the corner trackers in order to set a standard 4-point tracking procedure. And we'll look at that in another tutorial.